I'm going to be talking about basically worst things you can do in Oracle Analytics. And as I love this movie so much, I called it 50 Shades of Fail because that's just the worst thing out there. Very quickly about me, who am I? So my name is Christian Berg. I run a company called Dimensionality in Switzerland. We're doing business analytics, data visualization, data warehousing, etc. since quite a long time. Personally, I'm doing this since almost 17 years now. Started with an acquisition done by Siebel, which has in the meantime been bought by Oracle, which I came into this whole fold of Oracle products. I'm an Oracle ace. I speak on Oracle topics all around the world. Some of you may know some of the conferences, Open World, Kscope, quite some user groups, etc., etc. Sometimes I can be bothered to blog. Most of the time I can't. That's the reason why you normally find me online, either on the Oracle TechNet or on our different IRC channels or Telegram groups on Oracle Analytics. By the way, if you want to join there, please feel free. We're quite a bunch of people there, constantly talking about everything Oracle and Analytics. I also train this stuff for Oracle themselves at their university. And although I'm quite a geek and a gamer, note, I'm not a developer. So I know this is the Riga Dev Days and I do a lot of development, but I'm not a developer by education. I actually have a business degree. I just got into this whole thing because, well, it's business analytics. So we need the business part. Right, so why this presentation? Why am I talking about this stuff? Just quickly, who here knows the Oracle Analytics product suite? Who knows the Oracle Analytics products? 1, 2, 3. Okay, some. Yeah. I see Brendan shaking his head. Don't believe him. Right, so Oracle Analytics as a product suite is around since quite a while and is quite mature in respect to other products and is quite widespread. So for a lot of people, this means implicitly, well, it's a commodity know-how. There's a lot of people out there doing it. It's very well known. Unfortunately, it isn't. This consideration of commodity leads to a lot of very bad development. So that's the reason why I started with this Back2Basics presentation series. And obviously, if someone else ran into the wall and you can laugh about him, then it's a lot easier and funnier than when you yourself run into that wall. Little disclaimer, no, not the usual Oracle Safe Harbor statement. Everything I'm going to show you is actual live stuff from productive environments, from clients, integrators, etc., etc. So nothing that was like, oh, we're going to try out something or we're going to do a proof of concept and, well, proven the concept, it doesn't work. This is all real stuff. You will find it out there. I hope none of my clients are in here. And yeah, there's going to be a lot of text in there because I really want to spell out quite some things so that people trying this out in their own environment or being faced with the situation can actually have a step-by-step guide, but rather listen to my stories. They're a lot funnier. So very quickly, I added a couple of slides to this presentation because I already assumed that there's going to be a lot of people not very familiar with Oracle Analytics. So Oracle Analytics is a product suite built around the core of an engine that was written by a couple of very, very clever guys end of the 1990s. Yes, this stuff is still around. Yes, it still works, which just proves how well written that was in the beginning and how sound the concepts are. So Oracle Analytics is basically a analytical platform that allows you, metadata-based, to create common information models across all the different sources you can encounter. I mean, literally anything there is, either natively or if you can write an OBI driver for it, you can access it. You have multiple different ways of then delivering the information through either mobile. Everything is natively mobile anyways nowadays, so no need to build it again. Interactive dashboards, published reporting. What Oracle means with published reporting is actually pixel perfect reporting, meaning I need a watermark, I need a logo exactly at that pixel location on my printout, etc., etc. Then ad hoc reporting, web interface and Office integration, obviously. Then we also got data visualization, which is more kind of a new way of visualizing information, less dashboarding or reporting oriented, but more as in data discovery. Again, also mobile authoring and keyword queries. I'll come to that a bit later. And last but not least, we got the so-called data mashup features in there, which basically allows any user to combine the curated information that your IT provides for you with anything you can just upload as an Excel file and combine it, analyze it together. For example, you got your latest budgeting numbers and you just want to quickly bang it into the system and combine it with your actuals. So you can do this. How does this work? We got at the core of this whole thing, we got the so-called enterprise information model with 3 different layers, a physical, a semantic, and a presentation layer, over which we do the sourcing and through which we also assure that in the direction of the front end, or whatever front end you want to use, because you don't have to use Oracle's own products, you can plug whatever you want on top of this metadata engine. It's transparent. You don't need to change all your front ends every time there's a change in the back end. So very quickly, just one slide. Oracle Analytics Cloud, this is basically the new kid in the family. I'm going to talk a bit more about this tomorrow in my second talk, because I didn't want to cut off too much time for today's talk. So if you're interested in how that all looks in the cloud now, I'm going to be spending a little bit of time on that tomorrow. Right, so let's look at the categories of fail that we're going to analyze. First of all, the 3 RPD layers. So the RPD is that metadata engine that I was talking about. So what can you do wrong, or what goes wrong in these 3 layers? Then some system, DevOps, and security stuff. Multidimensional. Again, a question, who here works with multidimensional data sources? 1, 2, 3. Wow, okay, cool. So 3 people know what a cube is and will recognize some of the stuff I'm talking about. That's good. Some front-end stuff, good for the front-end developers. More specifically into analysis and dashboard design. And then in the end, more as a joke, well, a joke of jokes, if you go just way too far. So this is just out there and ridiculous stuff to do in an analytical environment. Right, let's start with the 3 layers of the repository. So first of all, in the physical layer, one of the things I often find done wrong in projects is incorrect handling of data types. So as I said, we can connect to any data source that we have. We can connect to Hadoop, we can connect to a Microsoft Analysis Server, we can connect to an XML file, we can connect to, obviously, Oracle databases, etc., etc. And not all of those data sources handle data type the same way. So we have to find like the lowest common denominator for a lot of these things. And one very special case that is like a tripping stone for a lot of people is integer versus double. So you might think, wait, why? Well, yes, in your data source, you might actually store it physically as an integer. That doesn't mean that Oracle BI interprets this integer the same way as it does your data source. And if I show you an example afterwards, you will immediately know, or you immediately discover why. So this is actually not something that just happens to, you know, as we can say, to script kiddies out there. This actually happens to big companies as well. Anybody remember this? Happened a couple of years ago. So from this counter, you can already see what kind of integer did they use. I mean, you're developers. You have to know what kind of integer that is, like right away. Know what? A 32-bit signed integer. So they actually use a signed integer to count the number of times a video has been viewed on YouTube. Why would you use a signed integer for that? I mean, you can't -1 times watch a video. It will always be positive. So they ran into this, and well, guess what? Oracle BI internally uses integer as a 32-bit signed integer. So rather go for a double or a number if you run into this. Next one, randomly setting database features. once more, since we can connect to anything there is, we have a lot of features that are possible in the different databases. So we can leverage functionality that's built into the latest SQL Server release, that's built into the latest DB2 release, that's built into the latest Essbase release, etc., etc. Obviously, these are very specific. And people kind of have this unnaturally, rather unnatural habit to just go on, okay, I have a performance issue or something doesn't bring back what I'm expecting to do. I'll just Google it, I'll find some blog post. And the guy said, oh yeah, I changed this database feature and everything worked 50 times faster for me. Well, guess what? If it works for you, it will be by chance and not by design, because you actually don't know what you changed. It's just because some guy said it on a blog. And this actually impacts very, very heavily the SQL or whatever language it is we're speaking to the source. And troubleshooting can be a real pain, because there's at the moment about 190, 200 of those. And if you have to go through all the different checkboxes and say, okay, I have 60 different sources times about 200 features, well, good luck. And if you look at the list of currently supported data sources, so this is from the Oracle Analytics Cloud version, so the very last one, you can see this is everything that we can speak to natively, which means Oracle BI will speak the dialect of that platform underneath. And you can imagine how much impact you can have on the physically generated query that comes out if you play with the features. So this is something more specific to Oracle databases as a source. It's very common to see something like this in a physical star schema in our metadata. Oh yeah, we haven't prepared the data right, or we're just doing cross-schema joins or so, and we don't actually have matching data types. So we're just gonna, do a toDate or cast or something, and let's get it together. Well, if you're an Oracle DBA, you immediately know what will happen with that. Well, there's no optimization anymore. We'll just do full table scans on both sides, get back the full data set, and then do an in-memory stitch join based on the complex join condition that you've specified. It's a nice feature because it allows us literally to do cross-database joins, but again, in terms of performance, it's not a good idea. Then I said there's a lot of sources we can speak to natively, but we have always the possibility to use ODBC, which is pure basic ODBC, to connect to the sources. The thing is, in some environments, we don't have all the drivers available. We're tied to corporate IT, to their rules. Are we allowed to install stuff on the servers? Most of the time it's, oh no, we're actually run the company, you are build the stuff, and you don't have the right to install things on the server. You have to hand in a change request, and in 3 to 4 weeks, maybe we will give you the necessary drivers. Well, great for our project plan. So people go and say, well, we're just going to do ODBC. Again, think of function shipping. Think of leveraging inbuilt functionality in your data sources. Will that work? Well, the BI server does the work. It will not function ship anything to the source. So if an Oracle function, for example, will give you back 200 rows on an initial set of about 2 billion, it's cool. If you do it over ODBC, you will get back 2 billion rows. Lovely. And yeah, performance. Let's go one level higher into the business model layer. So this is where we do the logical modeling of everything that we're building underneath. So we have the possibility to actually control whether the calculations we do happen pre-aggregation or post-aggregation. And this is something, and that's why I'm insisting on this word unwittingly, that a lot of people do wrong because they don't know the impact of it and are not aware of what that means. So basically we have two ways of writing functionalities and calculations in Oracle Analytics. The one is derived calculations. So we can just say, okay, we have logical columns that are coming from n different sources. We can just say in this case, okay, we divide the fixed cost by variable costs times 100, so we have a ratio expressed in percentages. Nice. This happens post-aggregation. So that means first it will get based on the dimensionality that you're looking at, the result set for the fixed cost, the result set for the variable costs, and then divide those two result sets one against the other. If we map stuff physically in the sources, those execute pre-aggregation. So if we actually write the same functionality as a physical mapping, we actually divide like columns in this case, one against each other. Well, it does look very different. So on the left, we have the row-by-row level granularity of the database. So we actually force each single row that's parsed to do the division and then the times 100. Here, we do it based on the result set. So you can already see both numbers have their validity. Both numbers can mean something to your business. But it really depends on what are you trying to report on. Do you want to do country totals by total of years? Or do you want to do every single, for example, sales transaction you have done in your last year, and then do an average across all of those singular values? So in terms of ratios, it's quite important to grasp this difference. And this is one of the really most misunderstood points of the business model and mapping layer. And obviously, you can get nice wrong results, and then you're sitting there going, oh, great. Then a good one, which is quite a mouthful. So creating multifactor models with non-conform dimensionality without properly configuring LTS content levels. And I'm going to have an example for that. So this is literally the most misunderstood part of the whole Oracle Analytics engine. We can do cross-star queries, we can do cross-database queries, we can do cross-source queries, we can combine an SSpace cube with an XML sheet, we can combine a DB2 result set with Teradata, etc., etc. But for that, obviously, we need to tell the metadata engine, listen, the data is coming back from source X, is on, for example, the year level, whereas the data is coming back from source Y is on the day level, and we got another one that doesn't have any notion of time in there, it's just geographical information. So if we need to join this all together, we need to be specific. So, and if you are not specific, obviously you will be missing result sets if you do cross-star queries. Some analysis just won't run, they will literally run into a wall. A lot more on this, by the way, tomorrow, and you'll get wrong results. Very, very simple example. I have two facts, sales measures and time-based measures. And as you can see, both of them are analyzable over time. But, well, our time facts were just yearly totals, but not broken down, in this case, by product. So, well, guess what? No relation. And then if you go into the definition of the logical dimension of this, you will see, yeah, we actually have information at the day level for the time, but we have no indication as to how should we actually aggregate this across the product dimension. Now, if you run this, you'll get something like this. Oh, well, there's nothing coming back because I'm actually doing a split by year and by product, and it doesn't know how to handle this. So we can actually go in and say, well, we force it to just say, okay, sum up by the grand total of products. And if we run this, then we can see another nice little result. Hey, guess what? We can actually count the number of days for all the years where we don't have products. And here, well, we have days and our sales numbers. So we can already see, yeah, obviously, for a pure dimensional query, we can count the days in the years, even if we don't have revenue, and now vice versa, we can see it nicely shows us our revenue. So we could do our average revenue by number of days in that year. Right, so special case for this, this so-called enable dimensionality. This is a new variable that was introduced a couple of years ago for especially all the cloud products and more let's say, for the desktop reporting products as well. So what this does is it tells the engine if there's nothing that specifies what kind of content the dimension contains or the fact, just assume a grand total and bring us back numbers. which is really cool for stuff like the Business Intelligence Cloud Service, data visualization desktop, and Visual Analyzer. That's what these nice little abbreviations mean. It just takes too much space. So they assume that the enable dimensionality is always true. Why? Because if you're more into data discovery, you want to see something, even if the config isn't perfect. You want to see what's there. You want to have it come back. If we do like management level reporting or dashboarding, we actually want to be precise. We don't want to have sparse data sets like this. You don't want to present this to your C-level executives. No. They're going to come back and say, what kind of rubbish are you producing? Why are we not like outsourcing this to someone else or just fire these people? That's unusable. That's unacceptable quality. So the use case is completely different. And obviously, full Oracle Analytics still has more possibilities. So we can really be fine-grained in terms of what bring we back and where. So if you look at this is data visualization desktop, for example. If we just look at what's behind in terms of the query, you can see, okay, it actually does include this new variable, enable dimensionality equals 1, which just equalizes all dimensions and facts that are included in any given query. However, if we go into a full-blown Oracle Analytics, or nowadays Oracle Analytics Cloud repository, and check what's there, and you can see, well, we have our sales measures that can actually come from all these different places with all these different joins, with weighting factors, etc., etc. Well, one single variable just set to true and say, well, assume a total for everything, that won't work. That won't bring back the results that you're looking for. And seriously, if you're doing analytics and you think that setting one variable to solve all these issues, well, sorry. Yeah, there's the door. So, last one for the business model. Well, second to last. Dimensional hierarchies. Again, this is something you don't have to do. The tool doesn't force you to do it, because it gives you the option to just glance over it. The why, only one of them is, well, we used some other reporting tool before and we never had to do this. Why should we do this now? Well, guess what? Because people actually want to have hierarchical drilling possibilities. They want to have OLAP style plus-minus navigation in their GUI. So give it the metadata necessary to do it. Tell the tool what are the levels that exist. And jumping one forward with the time dimension, time dimension is always the easiest one because everybody knows year, quarter, month, week, day. Well, so do the same thing for your products, do the same thing for your customers. Give your users the abilities. They will thank you for it. They don't want to write their own aggregate statements in their front-end tool. They want the tool to do it for them. And we have everything. Yes, a very nice one is in terms of conform dimensionalities. One of the ways to wiggle your way around it is to create 1 equals 1 joins between different stars. So a couple of years ago, a nice guy called Jeff McQuigg in the States wrote a presentation about non-conform dimensionality aggregates and added this little slide here and said, oh yeah, you can actually do joins between facts or between non-conform dimensionalities and just put a 1 to 1, 1 equals 1 join specification in there. Well, can anybody tell me what will happen if you do a 1 equals 1 join between 2 fact tables? It will create a Cartesian product. And now fact tables in most data warehouses are quite big, if not to say huge. So people unfortunately stop reading at page 12. The problem is he spends the next 3 slides dispelling why this is a bad idea. People just go there, oh yeah, I googled it, I found it, 1 equals 1, yay, works. Well, yes it does. But, and the but is n times bigger than anything you can do here. So, jumping forward to the last layer of the repository, the presentation layer. So, a lot of people are used to writing SQL. a lot of report developers are used to writing SQL because they use stuff like Crystal reports, Actuate, Cognos, whatever, and they just write queries and queries and queries and queries. So they come to an analytics tool and think, ah, yeah, cool, I found the option, oh great, to do unions. So I can do, okay, this is my first subset, I do a union, I do a second subset. Well, why? This is, for us, quite pointless, because if we can do it in a metadata model, it will do it for every single use case you have. You don't have to write 20 union statements if you use it 20 times in 20 different analyses. You write it once, and the engine will take care of it. So, yeah, then for me it's always, so why did you even change the tool if you haven't trained your users, if you're just doing report development as you did in the 1990s? Little story on this one from a client I was at. They switched from, I think, business objects to Oracle Analytics, and had more than 2,000 distinct objects in business object that they wanted to migrate. And realizing that they actually didn't have a clue about what was behind, because they didn't even use the universes, they just had manually written SQL code. Someone of them was very, very proud, actually. They came around and said, well, Christian, hey, this is so cool. We found this functionality where we can actually take our legacy code, put it into a front-end object of Oracle Analytics, save it and chart on top of it. And I was like, yay, this is a disaster. So now they have 2,000 distinct Oracle Analytics objects. So can you imagine how much ROI they had from this project? Basically 0, if not to say negative. So presentation layer, this is more geared towards business user, well, and you as developers actually. If you're working for business users, think about them. Don't just keep your naming conventions that you have in your database, in your Airspace cube. That stuff goes out to business. That stuff is made for self-service analytics. Call it something nice. Call it something in the lingo of the business, not yours. Yes, you're building it, but it's not you who is important. It's the person actually using it. And you cannot imagine how much more acceptance you will get for a system when you actually speak the business language instead of the technical language. A nice little one is alias handling in the front-end layer. So, as I said, we have a decoupling of whatever tool accesses the metadata layer from the metadata layer itself. The only link between the two is the fully qualified name of an object. Normally that's topic dot logical table dot logical column. Which means that if you manage stuff in the background and all of a sudden your database changes, you switch from, I don't know, a Teradata to an Exadata, you switch from having stuff just in CSV files or an XML, and you actually say, well, now we're putting it nicely modeled into a database, because performance, in the background you can change everything you want, it will remain transparent. Even if you're using web services and 5 other applications are consuming the result set, they will not have to be adapted in any way. Now, the thing is, obviously, we can play with these names. We can give it aliases. One of the reasons why we have this is marketing doesn't call things exactly the same names as accounting does, or logistics, or HR. Every department has their own specificities. And, well, you can read through a lot of those things in detail, but generally, the big problem comes when you have too many of those aliases, and you don't know anymore whether your front-end object references an alias, an actual physical name. What happens if your geographical country name gets shortened to just name? Oh wait, someone else already created an attribute that's called name. Well, now we have a conflict. What do we do? How do we manage this going forward? So, quickly going over this because it's too specific for you guys at the moment, I think. I really want to go to the other topics as well, so system and DevOps. And here, one of my really pet hates is when people don't turn on usage tracking in Oracle Analytics. The whole platform of Oracle Analytics traces everything. Problem is you can actually turn it off. So yes, I had to add the last one because I actually was at a client where they did have a legal constraint where legally corporations are not allowed to track what their employees do in that country. So yes, that is the only valid reason I accept for not actually tracking everything your user does. Why should you do this? Well, guess what? You can't run any statistics without having the actual usage information. You have no clue who uses what. Imagine you just spent a couple of cool millions on a new analytical platform. You say, we created 200 new dashboards with like 4,000 new analytical objects in there. Who's using it? Well, nobody. There's like the 5 things that they used before. They're doing a lot of Excel reporting, and that's it. So what the hey? The other thing is people complaining always about performance. One thing is, obviously, you just wait until the phone rings and say, oh yeah, this is slow. Yeah, good, we're going to tune that one query. Well, now something else is slow. Okay, so we're going to tune that query. Now something else is slow. Oh, that's a file. Wait, we're actually going to see whether we can pre-aggregate stuff. If you have the information about usage, who uses what, how often, how long does it take? Do we have peaks, like Monday morning, they always do analysis A with like 50 dependent analysis behind. Well, you can tune the whole platform like that. You can actually plan for that. You can pre-aggregate information. You can store information in space cubes. And a lot of those things you can actually automate. So the system will go in, check what information is there in terms of usage. Does it take long, etc., etc. And then we can automatically spin off an space cube. We can say, okay, aggregate the product information by sales department and country on a monthly level every second day of the month for the last month. The engine does this for you. You don't have to do anything. You don't have to write your own ETL processes. So turn it on. If you don't, that's bad. And additional to that, in what we call the sample app, which is a pre-built demo application of Oracle for the whole Oracle Analytics stack, they have all that stuff built in. They have a whole range of dashboards, scripts, so pre-written scripts that do these things for you, that populate database tables, aggregate them, etc., etc. You can just get them, put them in your system, run them, and well, you got your tracking, you got your flows, you got your load over Sunday, Monday, whatever you want. It's in there. Use it. It's free, as in, it's free as free beer. Gratis. Yeah, the last one is really a good one. This is actually written in one of the Oracle white papers on the Oracle Analytics platform. It actually states turning off caching, so pre-writing information to disk, so it can be accessed instead of on the disk instead of through a query. Turning on caching is one of the best ways of tuning performance. No, it isn't. It's one of the best ways of hiding your performance problems, yes. But if it takes 5 hours to get stuff from the database and show it on the dashboard, it will also take 5 hours to write it from the database and write it into a cache file, which then maybe takes 2 minutes to display. Well, you haven't solved the issue. You've just pushed it under the carpet. So solve the issue. Don't hide it. Caching can be useful, yes, but you have to know why you use it, and you have to know how you use it. Because a lot of times people go in, oh yeah, right, I forgot. In order to have good performing, we must turn on caching. Well, and do you have a cache strategy of refreshing the cache, or will you just hit stale entries every time until someone realizes, oh, that's old, we should refresh that? As always, positives and negatives. Then another one, which unfortunately is in the same document, turning off logging for performance. So I don't know who wrote that initially, but if you go online, it has been retaken and reposted by so many people that it has become one of those, not urban myths, but actually, oh yeah, if you, by the way, turn off logging on the server, then your whole system will run faster. Well, every developer will and sysadmin will go like, oh God, who wrote this? Well, as you can see here, this is all real stuff, by the way. This is an Oracle document. A very clever guy called Tony Hiljula dispelled this a couple of years ago, where he went in and did literally hundreds of million rows queries in a couple of dashboards, and then showed the impact of no logging, low logging, highest logging, and it was just nothing. It was just nothing, because the server just logs information. It logs the query, it logs metadata information. It doesn't log actually the data. Come on. What do you think? So yeah, and that harks back to the other two. Oracle BI is a metadata engine. We don't store information physically anywhere. We don't want it to be stored in a third, fourth, 78th place. We want to get it where it lies. If we had to transport it again, I mean, what would be the point? So ask yourself, where can I solve my performance issues? At the source. That's the best place to solve them, because that's where they actually reside. Likewise for data quality issues. Don't use OBI to like put a nice rug over your data quality issues by doing stuff like, and everybody who's writing reports will say, oh yeah, but we're doing this all the time. We're creating bins that don't exist in the data. We're casting stuff because the data doesn't flow in nicely. And well, okay, I get it. Sometimes it's necessary. But again, you're hiding the problem. You're using performance where it's not necessary. You can actually ETL that stuff in the beginning. If you have to do things like this, if you have to do case whens or casts or whatnot, or God behold, evaluate statements, do them in the repository. Because again, the repository contains the metadata information, which means you do it once. If you do it in the front end or another tool which receives the information, like through a web service, through ODBC or JDBC, you do it n times for each single time you need it. Do it once instead of many times. Reduce it. A really good one is also storing information in the WebLogic LDAP. So WebLogic, the actually middleware host that all of this runs on, comes with its own integrated LDAP. So why would you use it? Well, it's there, and it's actually a quite useful LDAP. Thing is, this should be used for system internal administration and management, because it's a lightweight LDAP. It's a very, very basic one. So there's no password rules, there's no expiration, there's no automated user management, nothing. It doesn't comply with your security standards at work, etc., etc. It's there. Use it for like dev or so. Use it for admins. Do not use it for productive environments. Even Oracle themselves say, okay, you can use it if you're developing or if you're prototyping or so, but even they consider it unusable if you go beyond, let's say, 1,000 users. That's kind of the golden number they mention. I wouldn't say 1,000. I would say as soon as you want to use anything from your corporate IT and corporate security, use that. Do not use the integrated, so the embedded one. Yeah, this was a whole couple of slides. I pruned this a while ago. Oracle BI, so the repository and web catalog and all the other artifacts that lie on the disks. A lot of you developers will say, well, cool, so we can use Git, we can use SVN, we can use whatever source control tool we want. Yes. Problem is, with business analytics, it stands between IT and business. So neither side really wants to take responsibility for those unpleasant admin tasks like source control. Business says, come on, we're just interested in the numbers. IT says, well, it's a business project, so they should take care of it, and they should actually provide the budget. A friend of mine, Robin, wrote a couple of very good blog posts on this, links behind there. So if you want to go in detail on there, that's where I can find it. Application roles. So we do transform your corporate IT and corporate security into the Oracle Analytics world. We want to leverage what's there, obviously. Worst thing you can do is just get, for example, from your Active Directory, from your LDAP, a list of users and then create your own roles in the application and manage it. Try to work with what's there. Again, use what has been built. Your IT security guys will have a list of roles, will have a list of functions. Use those. Assign them to like a matrix organization that controls functionality, data access, functional access, etc., etc. Very last one. Again, this is a very, very specific case from a client that was just so outlandishly weird that I had to put it in. They had a bit weird kind of the LDAP setup and realized, Oracle comes along and does a little review about how many licenses they have and how many licenses they use, and they realized, well, with our setup, in theory, everybody in our corporation can access and use Oracle Analytics. Problem, because the number of licenses versus number of actual employees was about 1 to 100, so a factor, not 1 employee and 100. Corporate security refused to do anything, which forced us to do nice little LDAP queries asking for specific users. You can imagine the login was just horribly slow. It took about 2 minutes to log on to the application. Pushback, again, pushback. We implemented it, and as soon as the problem hit like corporate management level and they saw this really nasty performance here, they were like, oh, what's happening? Well, after that, the security department moved quite quickly. So you can actually use this as a kind of leverage. So, multidimensional. Very specific topic. Why is this a problem in Oracle Analytics? Well, multidimensional sources, a lot of people think, well, it's just a database like any other. Well, it's not. They don't behave the same way. Also, you will often hear, well, we're already doing stuff with these cubes. You know, it's in the Oracle family. It's actually an analytics application. It's an analytics product from Oracle. So it has to work together, right? It must. Well, no. A lot of the Hyperion products, which are also bought by Oracle and not built, they aren't analytical in nature. It's planning and budgeting, for example. It's not analytical. And hence, the sources aren't made for dynamic, high-speed access of an analytical nature. So they're not meant to switch out dimensions on the fly, drill, pivot, slice and dice all the time. They're good at number crunching. They're not so good at aggregating. Obviously, you can have huge performance impact on that. And we actually had the case of taking down whole Hyperion server farms just by building a couple of dashboards and people navigating around and drilling into the data and saying, oh yeah, now actually I want to see everything from our corporate finance on the day level for that specific day. Boom. And the whole thing just blew up. Frontend becomes quite unusable. And yeah, for you, let's say, MDX exposed people out there, sparsity and dynamic calculations will tell you something, and also why this is a bit of a problem in OBI. And we lose quite a bit of functionality if we have cubes that are built for, let's say, planning purposes instead of analytical access. Very specific case for cube utilization in analytical spaces is always the measures. Measure hierarchy versus flattened measures. If you look at, this is an outline of an Essbase cube in Oracle Analytics with a sample measure, and here we have our hierarchy somewhere. Where is it? Yeah, measures. So we actually have a parent-child, in this case, hierarchy of Essbase measures, versus here we have it flattened out. So what's the effect of that? You can already see, well, we have a hierarchy object and the generic measure that we can use in our modeling and in our analysis. Whereas if we go to the flattened one, well, we don't have a hierarchy. We actually have our profit, our margin, our sales as distinct columns, like horizontally spread out. And then if we go and do an analysis on this itself, you can already see here we get the tree of a profit and loss accounting which nicely rolls up into its parent. You can use the plus-minus style drilling, whereas if you have the distinct columns, it just becomes a pivot table like any other. So in terms of utilization, this really changes. So if you're starting to use Essbase or Microsoft Analysis cubes, think about this. How do we want to model this? How do we want to expose this? That's one of the reasons why we like to combine, let's say, relational sources and cubes in our analytical platforms, because cubes are very good at something that relational sources are very bad at, which is nonlinear aggregates. You could have that the gross margin is not just the result, in this case, of net revenue and net costs, but a fixed measure that has other, let's say, cross calculations in there. Yeah, and then let's jump forward. I'm in short on time here. Front-end usage. And this is, well, if there's one thing that I want you to take away from this, it's this one. Do not use Oracle BI as an Excel export tool. Oracle BI is an analytics tool. It's not a data pipeline. Well, you will all find yourself in these statements. Well, I have Excel. I always had this stuff in my Excel. So just send me every Monday an export, or I'll just download it, these 500, 600, 5 million rows. I put it in my Excel and I'll make my own pivot table out of it. And then I'll email this to someone else and he will mash it up with something and then email it to the CEO. Guess what? That's why we built these systems, that stuff like this doesn't happen. And we're going to have a bit more of this tomorrow. You see this little data push that happens. It actually goes from the database or any data source to the BI server, to the BI presentation server, to the browser, to Excel. So it traverses quite a bit. So why do you put stuff in your browser if you could just, for example, send it as a CSV file? Or, well, if you're doing pivot tables, guess what? Pivot tables is one of the functionalities in the tool. Just do it in the tool. And a friend of mine, Mark, was nice enough to Photoshop this, and I actually stand by this. This was last year in another presentation, and he's like, "Yeah, okay, yeah, I can live with that." Extension of this, obviously, Oracle BI out of the box isn't meant to do multi-million row exports. It's a visualization and analytics tool. Again, it's not an ETL tool, it's not a data pipeline, nothing. So if you actually start moving things around and changing the configuration to make it accessible and make it actually parse that much information, guess what? Again, real life use case from a client. Someone went in, I have to check it. So 5 million rows by 200 column PDF. It had alternating highlighting, it had dynamic rendering of images depending on certain values in there, etc., etc. And then he went and said, print to PDF. We had gigabytes and gigabytes and gigabytes of temporary files of the PDF engine trying to render this, and it took down the production server because the disk space ran out. That was really cool. The guy unfortunately still works there. Another cool thing, which is basically mangling things, is using OBI as a data entry tool. Well, analytics, by definition, has nothing to do with data entry. There's better things. I mean, Alex is around here and a couple of the other guys from the Apex community, and as most of the people here are developers, it's very easy to just write that stuff. Don't make a tool that's not made to do task A, do task A because you insist we want to use this. Oh, it's just a web application. Every web application has to support data entry. Well, yes, also every car can go around the Nürburgring. Still, I wouldn't do it in a Volkswagen Charan. You will roll it at certain points on the track, and you will roll it badly. Get a track car. Vice versa, I wouldn't drive my kids to school in an aerial atom. I mean, they will have fun for about one day, and then second is like, oh, Daddy, no, the wind in my face. For those who don't know the aerial atom, there's no windscreen. You're just exposed to the elements. Yeah, random setting of catalog permissions. So I mentioned the catalog earlier a little bit. That's the place that stores all the artifacts representing our dashboards, our analysis, etc., etc. Those are also security driven. They actually have permissions. Ah, yeah, we don't care about this because we will anyway control the access to the data, etc., etc. Oh yeah, thank you, dear admins. Oh yeah, we have already IT guys taking care of this. Okay, cool. So we actually ran into the situations where end users had the same level of access in terms of permissions. They couldn't see all the data, but functionally, they could still control the applications as well as any admin out there. Meaning that someone who didn't know what he was doing was just playing around, removing stuff, saying, okay, permissions, what is, yeah, that looks weird to me on my analysis that was built for me. I'm going to remove this. Well, guess what? He kicked out the admins, rendering half of the objects in the whole presentation catalog unreadable to anybody, even the admins. Yay! Right, a couple of small ones on the analysis and dashboards. In Oracle BI, rather than other, let's say, more discovery-driven tools like data visualization, visual analyzer, etc., it actually plays an important role of what you do in the GUI and what you click over. It's all point and click, yes, but watch out what you're doing, because there's something called the excluded section. So if you're developing, if you're moving along, and you say, okay, I want the day, and I want the customer number, and I want the invoice number, and then you realize, no, actually, I want to have a month aggregation by product for certain countries, but across all my customers. And you leave that stuff in. Well, you may have something like this, what we had before. Okay, we're actually on the product level and the year level, so aggregated. We have not much coming back from the database. Then you're like, oh, wait. We have this in the excluded because I was developing, or I forgot to remove it, or I just clicked it over inadvertently. Well, then you look at the log and you see, okay, 3 seconds, still is okay-ish performance, but my DBAs are complaining because, oh, 200,000 rows for this result set? Okay. Then you look at the actual log file for the query that gets generated, and you're like, oh, okay, right. Lovely. We have about 20 columns, 20 row grid, and this is, yeah, just brilliant. Again, something that helps users a lot is we can say we can include null values by default, smooth over problems in the data, and just generally show stuff where there's nothing. Okay. It's very nice, but again, data quality and data consistency issues shouldn't be solved by OBI. And if you just include null values all the time, just as with enable dimensionality, which basically transforms everything there is into a full outer join, it's not necessarily the best thing in terms of performance. Special case of what I said in the RPD, you can actually do all these post calculations in the front end as well. But as I said for so many other things, if you can push the logic to a single place where it happens, namely the repository, don't do it in the front end. If your application that's a client of Oracle BI, which receives information over JDBC or a web service, says, well, there's this new measure we want, we've built it in 50 different reports, well, guess what? We can do it as well, and we provide it to you once. Which means when the logic changes, let's say the aggregation rule, the calculation gets extended, there's a new dimension coming. We change it once. We don't change it 50 times or 500 or whatever. Yeah, this one I'm going to just jump over. And last couple of ones, just for, as we say, shits and giggles, if I'm allowed to say this, giving direct database requests. So this is, again, a nice functionality that exists in the tool in order to support business users. What this does is, it actually gives you an SQL or MDX interface to write your own queries against the sources you're connecting to. Important. Why you shouldn't actually give this to people like the guys I mentioned earlier with business objects? Well, A, you're bypassing all the logic you have in your business model, meaning if your metadata model contains also your data filtering, guess what? they can go in and query all your HR data over this. So don't give the functionality to everybody. Don't give everybody the ability to query any data source using this functionality. We can be extremely fine-grained in terms of security and privileges. Just go over it. It's worth it. Just don't say yes, all okay, yes, next, finished. Think about who you give what and why. Even worse, there's something called issue raw SQL, which is a URL parameter, which allows you to access another interface, which doesn't only allow you to emit physical SQL or MDX against the data sources, it allows you to emit logical SQL against the BI server, and even call some BI server functions like changing the metadata, updating the metadata, dropping the cache, rerunning some calc scripts, etc. So also turn this off. Also something that we see a lot, oh yeah, could we have a button that when you click it, immediately calls our Outlook and sends him, no, just don't, come on. There's collaborate features inside of the product. Use that. If you want to send it to someone who's not in the company or not using these features, then think about, should you really be sending this data to him in the first place? I mean, I don't know about you guys, but I have a lot of clients in the financial services industry, which are kind of, picky about who gets their data. Tiny little bit, especially in Switzerland. And then obviously using monstrous JavaScript text to have OBI basically behave like an ERP or any other web application, you know, input masks, validation, etc., etc. Don't. There's tools that do this a lot better, and we can just read anything they create. Again, we just go to data, read it, get it in. This is basically, this is it. So if there's any questions, there's still a couple of minutes left. Nothing? Oh, way at the... Just 1 second. He's coming up with the microphone
to you. Hi. You mentioned multidimensional databases.
Yes.
Specifically S-base, for example, right?
Yes.
So is it a fail at all using the S-base?
No, not at all. Not at all. It's just, it's a fail when you go in and think, all right, we have these S-base cubes. We will immediately be able to build some super nice dashboards and ad hoc analytics on top of that. Why? Because most of the times, as I said, the cubes are not built to support this. So I have huge sparsity. Something I see a lot is you have, for example, a periods dimension and a year dimension. Guess what? Those are two distinct objects. Time series calculations, like out-of-the-box time series calculations that the tool can do, like ago, to date, period rolling, which it does dynamically, are not possible if you don't have an actual time dimension that does the roll-up. So you would have to build one on your own. Again, the engine does the logic. Function ships whatever it can to the source, which in this case is, well, nothing, because you have to start with one single date and build everything else virtually. So the performance impact on the BI server would be huge depending on your cube. So it's more about the cube structure. If you really want to use S-base successfully inside of Oracle Analytics, then use analytically built cubes, so actual hypercubes, where you can cross things nicely and the intersections will bring back data. So you don't have to go in and say, well, in this dimension, on generation 7, I have to query on this member, and I have to include the other dimension on generation 4, because only then do we get data back. Well, teach that to an end user. Every time you want to create a dashboard, be sure to include this. I mean, end user will just say, okay, come on, forget it, I'm not using this.
Yeah, I know what you mean. I've seen all those things you mentioned.
Yeah, that's the reason why I say fail.